都没录。Okay, so we're now going to talk about pixel-oriented visualization techniques. This is a group of techniques where one observation is represented by one pixel on the screen. In this particular one, visualization method, for a data set with m dimensions, we will create m windows. Okay, so 1, 2, 3, 4, we have 4 dimensions, we'll create 4 windows. One for each dimension. Then we're going to map the observation onto the corresponding pixels in this M windows. So the first observation, his income, we're probably going to sort the income from the lower to the high values. And then we plot those individuals one by one. So the first individual has low income, and its credit limit is depicted here. Its transaction volume is depicted here. Its age is depicted here. So the corresponding any pixel on the same location in each of the window corresponding to one observation. Okay. And we're also going to apply different color, different shades to the pixel. The shades of the pixel reflects the corresponding values. Lower income going to have lighter color, and the high income going to have darker color. So when we represent all the observations on those screens, on those four windows, we will be able to tell that income and the credit limit are highly correlated. People with low income also have low credit limit. People with high income have higher credit limit. Although the credit limit, the speed of the increase, extent of the increase is smaller than the extent of the increase in income. Well, we also see that people with high income and low income have lower transaction volume than people with middle income or middle credit limit. We further could observe that income, credit limit, transaction, none of those are correlated with the age of the user. So the advantage of pixel-oriented visualization technique is that you can represent every observation on the screen because one pixel represents one individual, then you can actually fit a lot of observations in a small area in a window. And it can be used to visualize different patterns. And in this case, we can use, in this example illustrates that the pixel-oriented methods can visualize correlation fairly effectively. The second method that we're going to look at is geometric projection. We have seen those plots, right? Earlier we looked at the box plots, the scatter plots. Those are all geometric projection based visualization technique. In this example, we have a matrix of correlation. Actually, it's a matrix of scattered plot that we can see the same set of variables are on the column and also on the rows. And this allows us to see the scattered plot, and we can see that if you plot longitudinal with longitudinal, you got a straight line, right? They're the same value, they're highly correlated. This is just a diagonal line. But if you look at this longitudinal to latitudinal, you can see certain patterns in the data. Okay. There are other more innovative use of geometric projections. For example, Inspire is a technique that allows you to visualize topic distribution within a collection of documents. They provide two visual. One is called theme view. It's a 3D terrain map to provide a high-level overview of the article topics. So this diagram shows that within this collection, you have a set of documents that more or less related to each other because they fall on this pattern. You don't have a hill here. And here the label shows the topic. Those are the words extracted from the collection of documents. And you can see how strongly that topic is represented in this collection and how it's related to some neighboring concepts. Okay. In this visualization, this is called a galaxy view, where each document is represented by a star. And the light of the star indicates the strength, how frequently that topic is covered by this collection. One star may be close to another star because they share similar content. This is not, you can visualize it and see clusters of documents sharing different topics. Okay, so another geometric-based projection is parallel coordinates. I actually recently used this visualization to illustrate how data were randomly distributed. So this reminds me of a question that former students have asked is when to use what visualization technique. It really depends on what you want to do. A lot of times when we try to pick a good visualization, we try a lot of different things and see which one makes the best sense. And a lot of times we need a combination of multiple techniques to make things work, to really convey the main message in a most effective way. So earlier we saw the invisible residence in our bodies, where you see a tree, which is a hierarchical visualization technique, and then combined with bar chart, right? And a different color and the circles, those are all geometric-based methods. So it's not a recipe book when you have this kind of data, do this. Again, in data mining, very few things can be formulated in that way. But when you started to accumulate experience and it won't be that difficult. When you understand the different visualization techniques, you will be able to find a reasonable combination of techniques to carry to convey the meaning that you want to. So here the parallel coordinates has parallel axes. Okay, each axis represents one dimension. Okay, and this is useful for categorical values. At least it has, this works for numerical values. At least it has to be ordinal data. Okay, so every axis has the minimum value and the maximum value that defines the starting and ending point of this axis. Okay, then each line here intuitively it represents one observation, right? So this line. This is the iris dataset. That sepal width, sepal length, petal width, and the petal length are all are the 4 dimensions. And for each observation, we plot a line that shows its sepal width, sepal length, petal width, and petal length. We can also apply colors to our class labels. So here are 3 different species. are depicted using different colors. This way we can see that these three species can be fairly easily differentiated using those 4 variables. And then when you run all kinds of the algorithms, classification algorithm, whether it's decision tree or support vector machines, you will find their performance are consistently good. Okay. When I use the parallel coordinates this summer, well, I want to illustrate a group of authors' background and their years in doing different things. And my goal using this visualization is that this group of authors that's in my data set actually have very diverse background and different years. So this is a block of things that doesn't have the patterns. So I want to show there's no pattern using these parallel coordinates. Again, geometric projection is a very powerful tool. It can be flexible, used in many different ways. The third example that this is the fourth example actually I'm going to introduce is using those dots and metrics and graphs to visualize association rules. So we mentioned that association rules, often it's easy to mine many of them. Therefore, we need very powerful visualization tools to help us to pick the best visual association rule that we want to examine, because there's just too many. Look at all those dots. I don't know. This is 408,638 rules. Okay, those are all covered in this graph. So we can use those dots and the color of the dots to represent the strengths of the rules. The color indicates the lift, and here is support, here is confidence. So you can, ideally you want the high support and the high confidence and the high lift rules, but you can see in this case we don't have. A lot of cases support going to be small because data sets are large. Therefore, within this range, we will find high confidence and high lift result. This is another way that we can visualize rules. When you select a set of rules from here, you can put it into this kind of visualization to start to analyze. Now you can actually look at the rules itself. So this is the right hand of the left hand of the rules, and this is the right hand of the rules. Remember, the rule has a left hand and right hand. Buying diaper, also buying beer. So buying diaper is the left side of the rule, and the right side of the rule is buying beer, right? So this matrix allows you to actually examine a smaller set of the rules in more detail. Here again, the size represents the support and the color represents the lift. The darker the color is and the lift score is higher. We're going to talk about what lift is in the future lectures. This is additional. This is actually a more of a graph display of the visualization rules. It allows you to check every element, what element was involved in which rules. So as you can tell, just by visualizing association rules, you need a different combination of techniques. Okay, the next topic that we want to cover is icon-based visualization techniques. This technique has a history and it's still being developed today. The idea of icon-based visualization techniques is to use different icons and within that icon, try to map features in the data to elements of icons. So one example is Ch2 Vis. So what we can see here, the size of the head, whether it's thinner or rounder or even become oval, the angle of the eyebrow, the size of the mouth and the shape, the direction, those are all being used to represent features in the data set. And there is another example, stick figures. So here it's a little figure representing looks like a little person. The length, the direction, the angle that formed all represent certain features. Okay. Another example, tile bar, is I don't think it's used today. It was used for information retrieval tasks, in order to illustrate where your search term appears in a document. So this bar shows the location of the documents those search term appeared. I think Ch2 Vis and stick figures are the more representative examples of icon-based visualization technique. To be honest, the issue that I have with this kind of visualization is it creates a very heavy cognitive load in the user's mind. I have to remember, okay, what those means, every element of this, the angles, the terms. So it tells you, there is a guide to tell you, if you are a female, you turn this way. If the data is a male, this bar turns the other way. This one is one of the visualization produced by us using a set of census data a long time ago. This graph meant to show that women with higher education actually have low income compared to men. Okay. I think if you study this, you're probably going to see that, but I just found it's a little bit challenging. I like this life in Los Angeles visualization way better, because this card, the feature that mapped to the face is intuitive. It actually carries semantics. So, for example, the shape of the head indicates the affluence of this individual, or the average people living in certain areas in Los Angeles, right? So people with better economic conditions, their face are rounded. Middle ones a little bit thinner, and the low income people are really just need help, right? So it's intuitive, and you can also see their affection, whether they're happy with their life and all that. So you can see also the color indicates obviously the race. Yeah, so I feel like for visualization to work, it has to be intuitive. Don't make me to memorize too many things before I could make sense of a visualization. So those earlier examples are older ones, very classic. Some recent examples that I'm going to show you. Those two examples coming from UC Davis Visualization Lab. This is a scholar tree. So this tree represents one person, represents one person's scholarly life, this person's publication. Again, you have to memorize a lot of things in order to interpret this tree. But you can see this is a fruitful tree. So the first impression you have is this person is productive as a scholar. So well, if you read those small fonts here, you will be able to tell that in this tree, conference publications are presented on the left of the tree. Journal publications are on the right. Already you see the bias. The developers didn't consider books, monographs. It's just a paper or journal. Okay, computer scientist. It's paper. It's conference paper or journal. Okay, and the branches, where the branch starts indicates the year of the publication. And you can actually decide between this branch and that branch how many years that's going to cover. In this case, it's 1 year. So branch interval is 1 year, represents 1 year. A branch has two sides too, the lower side and top side. Lower side, the fruit that's hung on the lower side are all first author papers. Okay, so then on the upper part, that would be co-author papers, and all that. So if you read the details, you will be able to tell that those leaves represents how many co-authors there for this paper and all that. So it shows a scholar's productivity throughout its academic career. This is another icon-based visualization. It represents personal Facebook activities. Okay, so how many groups you join and networks and what the network structure of those. Again, you have to read a whole sets of things to understand what the leaves and the stem and the petals and the color of the petal, shape, size of the petal, and the internal part of the petal. Those are all being attached with some meanings. You can actually probably also use those kind of visualization beyond visualize a scholar's publication or Facebook activities. But again, I feel like icon-based visualization, the key feature is to make the mapping intuitive. That's 22 minutes already. I'm going to terminate this recording and start a new one.